Algebra 2, two variable systems of equations. Concept 3, teacher talk. So in this concept, you reviewed solving systems by graphing. So we have two lines here. Let's put each of these lines into a form that's more easily graphed, so into slope-intercept form. So with the first equation, subtract your 4x over, so y equals negative 4x plus 2, and with the second one, we'll add the y and then subtract the 3. Now, I do have a mistake there, and I'll catch it in a minute. So let's graph this first equation. It has a y-intercept of 2 and a slope of negative 4 over 1. So that's down 4 and over 1 to the right. So there's our first line. Now I have the correct second equation, y equals x minus 3. So that has a y-intercept of negative 3 and a slope of 1. So we can clearly see the point where these cross, and remember that is called, you got it, the solution of this system. And so we'll list it as an ordered pair, so it is positive 1, negative 2. Also, if you always want to check your solutions, if you plug that point in to each equation one at a time and solve, you would get true math statements where the left side of the equation matched the right side. Let's just review about vertical and horizontal line. Do you remember how to write the equation of a vertical line? It's so simple. It doesn't, sometimes you wouldn't even think of it as an equation of a line. It's just x equals any number, wherever that line is crossing x. And then horizontal equation is y equals a number. So examples could be x equals positive 2 and y equals negative 3. So for the vertical line, that means you would go where x is 2 and you would stay on 2. So that would force you to draw a vertical line. And for y equals negative 3, you would go up the y or down the y-axis to where y is negative 3, and you would stay on the level where y is negative 3, and you would end up drawing a horizontal line. Now, what two types of line would produce an infinite number of solutions? Well, those would be lines that have the same slope and the same y-intercept. Sometimes when they are in equation form, you don't always know it until you start graphing them. When you graph those lines, they just graph right on top of each other, so they appear to be the same line. What about lines that would have no solution? Well, these are lines that have the same slope. They're slanting the same steepness, but they have different y-intercepts. And lines in the same plane that do that, we call those parallel lines. Do you think you'd rather use substitution or elimination to solve the system? And then why? So pause the video, look at that. There's no right or wrong answer. You could use either method. And then when you come back, I'll show you which method I chose. Make sure that you make a choice and then write why. Okay, welcome back. Well, I chose elimination because I noticed that I could just multiply the bottom equation by 2, and then my y's would eliminate. So I rewrite my top equation. My bottom one is 2x minus 2y equals 26. So I end up with 6x equals 36, or x equals 6. Then I can plug that into either one of my original equations. I decided to plug it into the second one, and I solve for y, and so I get negative 7. So the solution of this system is these two lines, if we graph them, would cross at the point 6, negative 7. And if we plugged that x and y value into each of those equations, we would get true statements. All right, that concludes the highlights for Concept 3.